Have you ever wondered what the world would look like if light didn't exist? Would the word seeing even mean anything? And could we ever understand how light knows to move that fast, almost like it's obeying a secret rule of the universe? Today, we're diving into the mysterious world of light, a force that has fascinated humanity for centuries. Light is both the reason we see and the key to how we understand everything around us. From the sun and stars to surgical lasers, light has always been at the heart of progress and discovery. But where did this story begin? Let's rewind to around 500 BC in ancient Greece. A philosopher named Empedocles believed that light actually came out of our eyes and touched objects around us. Weird, right? No one back then really knew what seeing meant. But that was just the beginning. In the 2nd century AD, Ptolemy started measuring how light reflects, laying the foundation of early optics. Centuries later, in the 11th century, a scientist from Khorasan named Ibn al-Haytham completely changed the game. He was the first to prove that light doesn't come from our eyes. It enters them from the world outside. Using a dark box called the camera obscura, he showed how images form upside down on the retina. That simple idea would one day inspire the invention of the camera. Still, for centuries, no one really knew what light was. Was it made of particles or waves? In the 17th century, two geniuses, Isaac Newton and Christian Huygens, argued over this very question. Newton believed light was made of tiny particles traveling in straight lines. Huygens insisted it was a wave, spreading through space like ripples on water. Both ran experiments, both were partly right, and the mystery deepened. But the story didn't end there. In the 19th century, physicist James Clerk Maxwell wrote equations that changed everything. He showed that light is an electromagnetic wave, electricity and magnetism dancing together. It meant light wasn't just something we see, it was a form of energy filling the universe. Yet one huge question remained. Why does light always move at the same speed? In 1879, Albert Michelson made the first precise measurement. The number is mind-blowing, at about 299,792 kilometers per second. That's fast enough to circle Earth 7 times in 1 second. But it's more than just a number. It's the ultimate cosmic speed limit. Nothing, as far as we know, can go faster. Then came the early 1900s, and Albert Einstein. With his theory of special relativity, he flipped reality on its head. He said light speed isn't just constant. Space and time themselves bend to make it stay constant. Move close to the speed of light and time slows down for you. A minute for you could mean years for someone on Earth. So light isn't just brightness, it defines time and space themselves. But at the same time, light started showing behavior that blew scientists' minds. In the famous double-slit experiment, light acted like a wave, creating an interference pattern. But when someone observed it, it suddenly behaved like a particle. It was as if light knew it was being watched. This strange truth became one of the cornerstones of quantum mechanics. Scientists realized light is both a particle and a wave, depending on how we look at it. They called this the wave-particle duality. Today, that same idea powers technologies like solar panels, lasers, and even quantum computers. Take lasers, for example. They work by making atoms release light in perfect sync, producing a beam so precise it can cut through steel. In medicine, lasers correct vision and destroy cancer cells. But light didn't just transform science, it shaped our art and culture too. In the Middle Ages, stained glass cathedrals used light to create an almost divine atmosphere. In the East, Persian and Indian architects turned shadow and light into poetry carved in stone. And in the 21st century, light entered an entirely new chapter. In 2001, scientists at Harvard slowed light down from 300,000 kilometers per second to just a few meters per second. By cooling a gas to near absolute zero, they made light crawl almost to a stop. And in 2015, researchers went even further. They actually stopped light for several seconds. They managed to store light, like freezing time itself. That breakthrough could someday lead to computers and memories that run not on electrons, but on photons, the particles of light. Meanwhile, light continues to amaze us on a cosmic scale. When you look up at the stars, you're literally seeing the past. Sunlight takes 8 minutes to reach Earth, but light from the Andromeda Galaxy began its journey 2.5 million years ago. You're watching ancient history every night. With telescopes like the James Webb, scientists are now looking 13.5 billion years back, to the moment the first light in the universe was born. That was when darkness ended and the cosmos lit up for the first time. If we think about it, light isn't just what reveals history, it is history. From the first torches in prehistoric caves to today's ultra-precise lasers, the path of light mirrors the path of human understanding. We built cities with it, measured time by it, created art through it, and mapped the stars because of it. And yet one mystery remains. Why is light so special? Why does a photon have no mass but still carry energy? Why can it move forever and never grow old? When light passes through us, maybe it's reminding us that truth depends on perspective. And maybe, just maybe, light itself is a reflection of something deeper than physics. Something between science and meaning. Until the day we find that answer, every flash of light, from sunrise to the glow of your phone, is a message from the universe whispering, there's still more to discover. So tell me, Len, if light could speak, what do you think its first words to us would be?